Yeah, now we are in live stream. We will start our today's second day of 3 days online training. Namaste, good morning all. On behalf of NIDM, I am Gautam, Junior Consultant, JS and DOC. I welcome you all to the second day of 3 days online training program on disaster risk reduction and resiliency, organized by National Institute of Disaster Management in collaboration with MT Lucknow. Before we starting our second day webinar, I could like to convey my sincere thanks to ED NIDM and Professor Suryaprakash sir, Head GMR Division and CBRN Industrial and Cyber DRR Division, NIDM, MHA GO, Government of India, Delhi, for giving this opportunity to conduct this 3 days online training program. And also, I could like to convey my sincere thanks to Dr. Anil Kumar Tiwari sir, for VC, to take over the moderation.
Okay, thank you, sir. So very good morning to one and all present here. Today we will begin our technical session of the. We start our session. I extend my hearty welcome to Dr. Amit Sinha sir. Sir is the scientist SE in the head and the training division of Remote Sensing Center UP. Sir has done his MTech from Applied Geology from University of Roorkee. Sir is acting as a head of the training division of the center. Sir is also acting. Sir has also worked as a regular faculty member of MTech programs of remote sensing and GIS by the School of Geoinformatics Division at the center. Sir is the project manager of the Natural Resources Data Management System (NRDMS) project. Sir is also acting as a nodal officer at the center of the Integrated Grievances Redressal System. Sir has published more than 25 research papers, 37 technical reports, and 6 atlases. Sir has received the Karm Yogi Award for the Best Employee in the year 2018. Sir is awarded by the Certificate of Successful Completion of 9 training programs. Sir has attended many conferences, workshops. Sir has organized Uttar Pradesh State Meet 2018, promoting space technology based on the tool land application in governance and development. So we welcome you, sir, in the today workshop, and over to you, sir.
Good morning to all of you.
Good morning, sir.
Thank you, Dr. Upasana. First of all, I would like to thank the organizer, mainly NIDM and MIT University Lucknow campus, for entrusting me the responsibility to deliver a talk on a very important aspect, that is how geospatial techniques can help in mitigating the flood disaster management. I would like to tell you that the flood is the most commonly occurring disaster, specifically in the part of Uttar Pradesh and other parts of the country also, in comparison to other disasters like landslide, earthquakes, drought. So flood is a very important disaster which we have to look after in a very systematic way. And for that, these geospatial techniques that includes remote sensing, GIS and GPS, lidar, bathymetric, drone surveys, they can provide you the amicable tools in mitigating the flood disasters, how you can report during the flood, how can you provide information about the land, how can the affected person in that particular flood. Because it is my personal perception, and after the lecture, this will be the perception of you all also, that without having these techniques, you cannot provide the exact and accurate information, and that is on time during the flood about the disaster. So it is very important nowadays that we should learn what is geospatial techniques and how it can be applied in flood disaster management. So today I am telling you my good technology and legislation in flood disaster management. But before going into detail, I would like to tell you something about the geospatial techniques, mainly remote sensing, GIS, and GPS. So I start with the remote sensing technique. What is remote sensing technique? Basically, it is remote sensing basically is a technique or tool by which the information can be gathered about any object which is naturally available on the surface of the earth by detecting its behavior in different wavelength region of electromagnetic spectrum that we receive from the sun. So for carrying out a remote sensing technique, we have to have a device by which can we record the behavior of object through EM spectrum, how it interacts with the EM spectrum. We are getting the spectrum from natural resources like sun, radiation coming from the sun through the atmosphere interact with that radiation, and after interaction with atmosphere, radiation, part of radiation reaches to the earth surface where objects are naturally available, and those objects are interacting with those radiation received from the sun, and after their capability and their chemical composition, their physical composition, they can absorb certain amount of radiation and एक घंटे बाद नमस्कार एक घंटे बाद they can absorb the radiation which we are receiving through the sun depending upon their capability, and that which left they are reflecting back. So those reflected radiation are being received by the satellite sensor which are orbiting in the space, and after recording those radiation, these information sent back to the earth in form of signal, and for that we have created a data receiving station that is located at Shadnagar, Hyderabad in our country. So where we receive the signals from the satellites, and after receiving those signals, we have to do the signal processing, we have to process the data and produce in two different forms, that is hard copy data format and soft copy data format. And after getting those data, we are analyzing it or certain tools and techniques, which we will discuss in later. So after getting the satellite image, we are providing the information to the user. How we can extract those information, we will tell even later on. Next slide. Here you see, I would like to tell you something about electromagnetic spectrum. What is that? It is a very wide range that is starts from cosmic to radio waves. And I'm telling you that remote sensing nothing to do with the cosmic rays, gamma rays, X-rays, ultraviolet rays. Our role comes in the field of visible light only, because visible light has red band, blue band, and green band. So this particular visible light range of a spectrum is mainly responsible for remote sensing techniques. But after the evolution of these techniques, infrared light also came into the picture. So these are also being used in remote sensing technique. And some years later, microwaves also are being used in the field of remote sensing. And finally, radio waves, these are also being used in the field of remote sensing, but mainly for GPS, global positioning systems, GPS satellites. Next. Here you see the behavior of natural object in visible range of EM spectrum. You can see the curve on which the cursor is moving. So here we have given certain values of reflectance percentage, that is radiation reflected back by the object to the satellite sensor, and on the x-axis there is a wavelength range. So you see here that in blue wavelength range there is certain amount of radiation is reflected back by the object, and at green band and red band also. But when it reaches to the near infrared range, that is 0.7 micron to 0.78 micrometer, it touches the x-axis. This means no amount of radiation is received by the satellite sensor. This means the object has observed total radiation which received from the sun. And that particular object is clear water. So the clear water has the capability or peculiarity that it absorbs 100% radiation in the near infrared range of electromagnetic spectrum. So no information goes to the satellite sensor, and when no information received by the satellite sensor, that particular object appears as a black body object. So whenever you see the satellite image, if you find any black body, any black object, that is certainly having water component. And depending upon the turbidity in that particular water body, its color changes to dark blue, light blue, and so on. Likewise, in the second curve, you see the green curve, that is the curve for vegetative objects. It has peaks and troughs for certain amount of wavelength ranges, and that is because of that we have a very wide range of vegetative cover on the surface of the earth. We have small grassland to dense forest. So having the capability of this peak and troughs in the spectrum range, we are able to distinguish different type of vegetative object. Next slide. So what I am telling you the stages of remote sensing, what is basically happening in this technique. First, you have to look after the source, that is sun. Energy transmitted through the sun, that is A. Radiation comes from sun to the atmosphere, that is B, denoted at B in this particular picture. Here, atmosphere plays a very crucial role. Atmosphere interact with that radiation and it reduces certain amount of radiation in form of diffusion and emission and block certain amount of radiation. That is, for example, ultraviolet rays. Ultraviolet rays are being absorbed by the atmosphere. That's why it's not reaching to the Earth's surface, and we are safe without that. So after interaction with atmosphere, that is B, the amount of radiation reaches to the Earth's surface, where one object C is waiting for that, and it has interacted with the solar radiation. So depending upon the capability of object C, it absorbs certain amount of radiation, and whatever the amount radiation left, it is being sent back to the atmosphere, through atmosphere to satellite sensor, that is denoted at D in this particular image. And where satellite is orbiting in the space, satellite having a sensor recording those radiation, and after recording those radiation, it is being sent back to our ground receiving station, that is located at Shatnagar, Hyderabad, where we process the data and produce the data in two formats, soft copy format and hard copy format. And after analyzing those data, we are able to provide certain amount of thematic maps and related data. Next. So this is in short the remote sensing stages. Now you should know about the satellites. How many type of satellites are orbiting in the space? The satellites which we are dealing with and which we are talking, that is sun synchronous satellites or remote sensing satellites or polar satellites, because their orbit is near polar. They are orbiting in the space from North Pole to South Pole. And these type of satellite passes over all places on the Earth. Like this, North Pole to South Pole. Back. And entire globe is covered on regular basis. And that's why we are getting the repetitive coverage on periodic basis. Why we are getting the repetitive coverage? Because if the satellite is orbiting in the space, so if it starts from one place and after complete one orbit, it reaches the same place again. For example, if the satellite has taken the picture of Lucknow city as of now today, so after completion is one orbit, it reaches to the Lucknow city again. And how much time it will take? It will take 24 days. So orbital period of these type of satellites are 24 days. So after 24 days, we will again able to get the satellite image of that particular area. That's why we are getting the repetitive coverage of on periodic basis. So whatever the changes took place during the 24 days, we can monitor that and provide the information. And that is required for flood disaster management type of studies. Highly required, because no other technique can provide you the repetitive coverage. How do you will monitor the changes? So with the capability of providing repetitive coverage by the satellites, remote sensing satellites, basically, it is possible to monitor the changes. And that is a very important tool for getting the information about this type of flood disaster management. Why these satellites are being called as sun synchronous satellite? You need to be understand that, because we are getting the radiation from sun, and our earth is revolving around the sun. You know all that. And these satellites are revolving around the earth. So the revolution of earth and satellite are synchronized with the sun. As the earth moves from sun from one particular direction, satellite also moves in the same speed, so that it will get the proper illumination through the sun. That's why you will be able to get the picture of that particular portion. So that is why these satellites are known as sun synchronous satellites. All these type of satellites are being used for natural resources studies, disaster related studies, and environmental studies. These type of satellites are orbiting in the space at a certain height. There is a range from 700 kilometer to 1000 kilometer. So all the remote sensing satellite or polar satellites or synchronous satellites of each and every country that is having an altitude of between 700 to 1000 kilometer. Now we are going to reduce certain amount of altitude. Second type of satellites are geostationary satellites. Geostationary matlab, geo means earth, stationary means fixed. So here you see the also in conjunction with polar satellites. So their orbit is not from north to south pole. It moves from west to east. But their orbit is fixed. They are not moving around the earth. They are constantly watching the same area of the day and night from the earth's surface at a distance of 36,000 kilometers. So these satellites are equatorial west to east satellites. They are orbiting Earth at an altitude of 36,000 kilometers, and they makes one revolution in 24 hours, not in 24 days, like sun synchronous satellites. These satellites are covering the same area day and night, and their coverage is limited to only 70° north to 70° south latitudes. Only 1/3 globe can be viewed through these type of satellites, but these satellites are being used for telecommunication and weather forecasting purpose. So we are not discussing these satellites because we are not dealing with now at present communication and weather forecast. These are being used by IMD department. And as far as India is concerned, our geostationary satellites are named with INSAT series of satellites. Whenever you see the national news, you are getting the information that as per the image received from INSAT, this particular place will be get shower, this particular place will be getting the heat of sun, this particular place it will be cooler. So on the basis of that information, we are able to provide the information about weather forecast, and telecommunication. The third one satellites are GPS satellites. These satellites are also orbiting in the space from North Pole to South Pole, and they are having the network of 24 satellites. And in one orbital plane, always there are 4 satellites in orbiting, and these satellites are used radio waves, and these satellites are being used for navigation purpose, just to provide your location on the surface of the earth, at which latitude, at which longitude, and which altitude you are at present standing. Here you see the different type of GPS satellites of different countries. America is pioneer with that. That is known as Navstar, and it has full command all over the world as far as GPS is concerned. That's why it is known as global positioning systems. But Russia and China are also not far behind. GLONASS is Russian GPS system, compared the Chinese GPS system. But our India is also competing neck to neck with these countries, these developed countries. Our country is still a developing country, but as far as space technology is concerned, we are not far behind, and we are giving neck to neck fight to these countries. So we have also developed our own GPS system. I should not say the GPS because we are not providing the global information through our positioning system and navigation system. That's why we are telling it as IRNSS, Indian Regional Navigation Satellite Systems. We have projected only 7 satellites, 7 GPS satellites in the space, in comparison to America, which has projected 24 GPS satellites for their global positioning systems. But we have projected only 7 satellites because what we have thought that we should not provide the information for entire world, as America and China and Russia also covering that. We should focus on the economy of country, and we should have our own GPS system, and the countries which are neighboring us, which they can also take the help of our GPS system known as, and our GPS system is in short form known as NAVIC. So these satellites are orbiting in the space at an altitude of 20,000 kilometers, not 36,000 kilometers, not 700 kilometers. They are orbiting in a space of 20,000 kilometers. Next. So as far as Indian space program is concerned, we have started our journey in 1975 with the launch of first Indian satellite known as Aryavat, followed by the Rohini series satellites. But at that time, we were not having the facility for launching station, launching vehicles, because if you want to project satellite in the space, you need to have a satellite launching station and launching vehicle as well. So after tremendous research in the field of space sciences, we are able to develop launching stations, launching vehicles, and in the year 1987, we have got the major success. On 17 March 1988, we have launched our own indigenous satellite. Indigenous means built in India, not anywhere, built in India. And this satellite has been projected to our polar satellite launch vehicle, and that to our own launching station that is located at Sriharikota, Andhra Pradesh. And this satellite launched in the space successfully, and it has provided a successful result as well. So this is a milestone in the field of Indian space program, 17 March 1988, when we have launched first successful remote sensing satellite, first indigenous remote sensing satellite in the space through our own launching station and through our own launching vehicle. So our space program is running with the aim in the mind that one satellite is having only 3 years period. 3 years period means it can provide the data for continuous 3 years without any deterioration. But after 3 years, data can be deteriorated. So scientists have thought, if we required more years to develop the advanced sensors and other things. Then we have to launch the same satellite, identical satellite, before completion of 3 years. And with that, we will be able to get another 3 years for research. So likewise, our space program is running. We have launched first successful in 88, IRIS-1A, Indian Remote Sensing Satellite 1A. The identical satellite of IRIS-1A has been launched in year 1991, that is known as IRIS-1B. These two satellites having the multispectral sensor LIS-1 and LIS-2, linear imaging self-scanner system. LIS-1 has the capability of 72 meters and LIS-2 has the capability of 36 meters. What is 72 meter and 36 meter? That is the spatial resolution of those satellite sensor. And what is spatial resolution? That is the ability of the satellite sensor to provide the information on that particular element of the surface of the earth. This means LIS-2 can provide the object which is having area 36 by 36 meter and more than that, not beyond that. But LIS-1 has the capability of only 72 meter. So from LIS-1 satellite sensor, you will get the information about the object which is having an area of 72 meter by 72 meter and more than that, not beyond that. So when we have launched our other satellite, remote sensing satellite in the year 1995, known as IRIS-1C, it has a different scenario. It has 3 sensors in comparison to 2 satellite sensors. It has panchromatic sensor, which cannot provide information in different wavelength bands. That is having the resolution of 5.8 meter. It has a LIS-3 sensor in comparison to LIS-1 and LIS-2 sensor, and LIS-3 sensor has the capability of 23.5 meter. Along with that, it has WIF sensor also, wide image field sensor, that is having the capability of 188 meter resolution. So likewise, we have launched IRIS-1D in the year 1997, identical to IRIS-1C, but in the year 2000, we have launched RESOSAT, and that is having the LIS-4, PAN, and WIFs, AWIFs, advanced WIFs. So LIS-4 sensor has the capability of 5.8 meter multispectral images, and LIS-3 has 23.5 meter, and advanced WIF has 70 meters or 56 meter resolution. And after that, we have launched RESOSAT 1, RESOSAT 2, RESOSAT 2B, Cartosat, Cartosat 2B, Cartosat 3B, and we are progressing like anything. So we are very well advanced in the field of space sciences. Next. Now the question comes, why we have chosen the satellite systems and space-bound platforms. The reason is that these type of platforms are not being affected by Earth atmosphere. Because earlier, when we were doing the survey work or getting the data from the field, we were using ground-based platforms. That is, has different type of limitations. Then we switch over to airborne platforms. Aircrafts are generally being used for that. We are getting the aerial photographs to that, but it has deterioration in aerial photographs. We are not getting the exact information about the object. So after that, it has been thought, if we projected one object or satellite in the space, then it will not be affected by the atmosphere, and they will be moving in their orbit around the Earth throughout their life. No problem at all. And इससे हमें we will get the information about the remote sensing data. Next. Here you see the view of India through satellite. One thing I would like to make it clear that here you seeing the geographical boundary of India, Sri Lanka, but if you are getting the satellite image, there is no geographical boundary. You are seeing it just because of it's conjuncted with GIS capability. Because GIS has the capability to clip certain boundaries and to fit over on the satellite images. When you are getting the satellite image, you will get a square image which has squared pixels, not any geographical boundaries. Here you see the true color composite and false color composite. What is that? The false color composite is a very important phenomenon in the field of remote sensing or satellite technology. As I have told you that satellites are having the sensors, and sensors have certain capabilities. Some sensors are panchromatic sensors and some sensors are multispectral sensors. Panchromatic sensors can provide information only in one particular band, and multispectral cell can provide in different spectral bands. So during the earlier days when we were doing the remote sensing technique, we have to analyze the satellite image for each and every multispectral band, and that is taking enormous time in getting the image analyzed. So what we had thought, if we merge these 3 or 2 band satellites images together, then we will not be analyze those satellite images one by one. So it will reduce our time. So it has been that, but the drawback is that now we are not able to analyze the satellite image as we were doing it earlier because the information get mixed up. So then we have thought, if we provide certain false color to it, then maybe it is possible that we will extract the information very easily. Then the role of false color comes into the picture, and after certain years of research, we have made a standard false color scheme and pass the satellite through those standard false color scheme. So after that, we will get false color composite. That's why you are seeing in India certain amount of red. That is basically the vegetative cover of India. But the vegetative cover naturally appears in green. You all see the plants are green, trees are green, leaves are green. But in the false color composite, it is being shown as a red color. Why? Why we have given red color to the vegetation? Because the intensity of red color is very high, and everywhere we have to point out certain things, we are using the red color like traffic signals, tail lights of cars, because it is eye-catching. And believe it, that our eyes are more tuned to the red color, and our eyes can distinguish different type of shades of red in comparison to any other color. And since we have to analyze or extract or observe a very wide range of vegetative cover, like from a small grassland to forest land, dense forest, we have taken the red color for vegetative cover. Next. Here you see the image is basically, it is also a false color composite. You see the image of Lucknow city, in which you are getting in the middle a very curvaceous line, that is Gomti river, and the right hand corner you are seeing the Kukrel forest, and in between the entire Lucknow city. Left hand side I have written tone, texture, pattern, shape, size, association. These are the elements on the basis of which we are extracting the information through these type of false color composite. Next. This is a false color composite of UP and Uttarakhand. Here you see the topmost portion, that is snow-clad Uttarakhand, Gangotri, Yamunotri and all that. And below that, dense forest of Uttarakhand. And below that, UP Ganga plains. Here you see the right hand corner, Vindhyachal range. And here you see the one blue water body, that is the reservoir of Rian Dam. Here I would like to tell one thing, that as I have told you earlier also, that once we are getting the satellite image from satellite sensor and get it analyzed, it has no color at all. It is only black and white. Why? We have two extreme object which has 0% reflection and other has 100% reflection. Clear water has 0% reflection, reflected radiation, and the fresh snow is having 100% reflection. So these are two extreme objects which we can observe through the satellite image. But what about the other objects? So clear water appears on the satellite image in black color, and the snow appears on the satellite image in white color, bright white color. So other objects which are having the spectral response between 0 to 100%, they are getting the color of mixture of black and white, that is gray. So single satellite image is always in black and white, and it has objects in different form of grades of gray. But after getting passed to the false color standard false color scheme, we are getting the FCC as we are seeing it now. This is the satellite FCC of Allahabad region, Prayagraj. Two rivers, Ganga River and Yamuna River. Ganga River is shown through blue color and Yamuna River is showing through black color. So here the theory comes when clear water is absorbing all the radiation, so that's why it appears black on a satellite image. So why Yamuna is appearing black? Why not Ganga? So reason is that Ganga is less deeper than Yamuna River and Ganga is more turbulent than the Yamuna River. So since Yamuna Nadi is deeper than Ganga River and its flow is not turbulent in comparison to Ganga River, so the sediments which are flowing through the river water are getting the time to settle it down deeply as far as Yamuna River is concerned. So only the reflection of water comes to the satellite sensor. That's why it appears black. But in case of Ganga River flow is highly turbulent. The sediments which are flowing with the river water are not getting the time to settle it out. That's why their reflection also reaches to the satellite sensor, and that is because of that they are appearing in blue color. Next. Here I would like to tell you something about the resolution of remote sensor, that is spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. So what is spatial resolution? I have told you earlier also, smallest elemental area over which independent measurement can be made. If the satellite sensor is having 30 centimeter resolution, this means this particular satellite sensor can provide information about an object which is having area of 30 centimeter by 30 centimeter, not beyond that. And as far as spectral resolution concerned, the satellite sensor capability of the sensor to resolve energy into different spectral bands. In how many spectral bands the satellite sensor can provide information. That is known as spectral resolution of that particular satellite sensor. Next. Here you see the difference in spatial resolution and how it affects your observation. When the resolution was quite large, that is 1 kilometer, you are able to see only few objects, 1 or 2. But when it reduces to 360 meter, 188 meter to 1 meter, you can see the difference in the satellite image. In 1 meter, you are able to map a single household in the city area. So this is the beauty of capability of spatial resolution of satellite sensor. Next. The third one, which is known as radiometric resolution, that is a very important phenomenon of satellite sensor. If you are getting the satellite sensor which is having a very advanced spatial resolution, then it should have also a very advanced radiometric resolution as well, because radiometric resolution is the ability of the sensor to distinguish finer variation of reflected radiation. As I have told you that all the objects are reflecting radiation depending upon their capability. So the objects which are very similar to in appearance and very similar physical capabilities and chemical capabilities, so in their behavior there is a very slight difference in fraction of percentage. So how you will be able to distinguish these objects? It is the ability of that particular satellite sensor which is having advanced radiometric resolution, you can distinguish as well. Temporal elevation, this means the capability of satellites that to revisit an area by the remote sensor at regular interval. That is known as 24 days of satellite remote sensing satellites. Next. There are two types of light sensor, passive sensor and active sensor. Passive means which are using the sunlight, natural radiation. But the active sensor, they can produce their own EM spectrum, EM radiation. This, for example, they are knowing as radar. You must be heard of that. Actually, here you see some glimpses of false color composite. I'm showing you because of that. You should know the capability of remote sensing technique. Here you see the river. Since we are talking about flood disaster, you see this river. It has certain active channels and it has certain dead channels also. It has a deposition of sand also. And if someone asks to mark active river channel of this particular satellite image, here I would like to tell you one thing more, that a single satellite image can acquire a very big area. It acquires 748 square kilometer in a single satellite image. And this particular capability of satellite image is known as synoptic view. Satellite sensors are providing synoptic view. So this particular image also is having 748 square kilometer area. And if one asks to map the active river channel, you can very easily map out these features in 1 or 2 hours with the available capability of remote sensing techniques. But if you are not having these techniques, you go in the field and through conventional techniques, you are going to map these active river channels. You will not be able to map precisely, as well as it will take much time. So this is the importance of remote sensing technique. Next, here you see the pictures of higher Himalayas, Tibetan Plateau and China Range. Here you see the two black objects. One is Mansarovar Lake. Next, here you see the FCC of Banaras Hindu University. You see the beauty of Banaras Hindu University. It is being designed in a semicircular pattern, and this pattern is visible only through satellite image, not through the ground. And when you improve the satellite sensor from 23.5 meter to 1 meter, you are able to map the trees, blocks, and other layout in this particular BHU campus. Next, you will see the glimpse of Lucknow city as well. You see the KD Singh Babu Stadium, which has a cricket ground and it has a cricket pitch in between, where you see no red color. This means the grass cover has been removed from the cricket pitch and the surrounding stadium is lush green. That's why it appears as a red color. Here you see the picture of Icona satellite image during the Kumbh Mela, and you will see the tents. Tents are being installed temporarily during the Kumbh Mela, and these are the bridges through which the pilgrimage are crossing the river, going from one side to another side. So it's a big task, but with the help of remote sensing, we can monitor these bridges also. We can monitor the tents also, how many tents have been installed, and how we are going to pay those contractors who has given the contract for installing those tents very precisely and very accurately with the help of remote sensing technique. This is the view of QuickBird image of Ottawa area. You can see the different type of trees, swimming pools, households. Very precisely you can demarcate. Next, here you see the Cartosat view of Bangalore city. Cartosat is having only panchromatic sensor. That's why it appears as a black and white image. You cannot get the FCC through Cartosat. Here you see the railway station and bus station of Bangalore city. At railway station, you can visualize the train, as well as at bus station, you can visualize the buses also. Next, here you see the agriculture land view of satellite FCC, and you can monitor plot information, plot by plot, which plot is having agriculture land, which plot is having no agriculture, which plot is having trees, and how many at which distance it is being planted. So very precisely you can demarcate the information and provide the users. Next. Next component of geospatial technique is GIS. So with the help of conjunction of GIS techniques with remote sensing technique, it is a very helping tool to all scientists who are working in this field, because GIS is a combination of hardware and software, and it can provide you to store the information, to manipulate the information, to analyze the information, and to produce the map in customized way. You can overlay different type of information through the GIS, and the latest capability of GIS is that you can upload the satellite image through GIS software as well. Earlier it was not available, so we have to depend upon the image processing software to just see the soft copy of satellite images. But now soft copy of satellite images can be uploaded through GIS software also, and it has provided amicable help to us in getting the extracting the information through the satellite images. So what we are doing, we are just uploading the satellite image in a computer system which is having a GIS software, namely ArcView, which is most commonly using GIS software, and we are opening the image in the backdrop of that particular system. And after that, next चलिए और चलिए next ये, and after that we are opening a shape file or create a shape file in that particular environment and just overlay it on satellite image that is in a raster format. And since the satellite image is in a backdrop, you can mask or trace out the different object on the basis of photo interpretation techniques, that is tone, color, texture, and all that. Next. Here you see the different type of shape files, line, point, and polygon. You need to have projection system also, because if you do not project the information rightly, then you will not be able to locate your information correctly on the satellite images. Next. GIS can, as I told you, that it has a very strong capability of storing the information, and it stored the data in form of a geodatabase. Next. Next is the component is GPS, Global Base System. It also provide very important information in the field of geospatial techniques. As I told you that it is being used for navigation purpose. So as far as advantages of remote sensing technique is concerned, your inaccessible area becomes the accessible, and it provides a synoptic coverage. A very big area comes at a glance in through your eyes. And third one is that dynamic measurement is possible, which helps in monitoring the changes and excellent monitoring system. So as far as flood is concerned, this with the help of remote sensing technique, you can provide enormous information that is in a very precise manner, in a real-time mode, and very accurately. Next. Application potential of remote sensing technique is in the field of water resources, earth resources, land use, soils, forest, glaciological, natural disasters, in all that. Today I will tell you about the water resources, especially for floods, flood inundation mapping. I will give you the example. Next. How you can do the flood inundation mapping through geospatial techniques. Here you see the FCC of Gorakhpur district of Uttar Pradesh. It is a FCC of pre-flood period. This means the image which acquires before the flood period. And you see here the two rivers are there in between the district, that is a Rapti river, and on the bank southern boundary of Gorakhpur district, that is Ghagra river. Next. You see the FCC of Gorakhpur district during the flood period. You see the changes. The water of Rapti River spread like anything, and Ghagra River as well. So you have to map these areas through satellite images very precisely. There is no difficulty at all. Next. Here you see the outcome of that particular information. That inundation mapping is being prepared in just 1 or 2 hours. So it is a very easy way to provide information about the flood inundation during the flood of any particular area. Next, the drawback is that as far as optical remote sensing technique is concerned, your visible range is concerned, flood always occurs during the monsoon period. And during the monsoon period, we are not able to get the sun in observation because the clouds come in between. So on the images, we are getting too much cloud cover. So we are not able to distinguish the ground features. To overcome this problem, microwave techniques comes as a very helping tool. Here is with the satellite image of any microwave satellites, that is Radarsat microwave satellites. It is a Canadian satellite. And here you see the same area, part of Gorakhpur and other districts. And the object which you are getting in the black color, that is water spread. You can very easily map water spread through the microwave satellite data during the flood time. One thing I would like to mind you that during the flood time, if someone has to provide information about the flood, a real-time data, how many areas has been affected by the flood, how many is going to affect. So without the help of remote sensing technique or geospatial, it is not possible at all, because you have being cut off by any means. You have no rail network, you have no road network, you have no connectivity at all. Just you can visualize through that helicopter this much area is submerged in floods, but you cannot provide information. But with the help of remote sensing techniques or GIS techniques or GPS techniques, you can provide the accurate information how much area has been affected by the flood. In the next view, here you see the information which we are providing through the flood inundation mapping. You can visualize that how many villages of this particular Gorakhpur districts are being affected by flood during that flood period. Well, you can precisely tell this particular portion of the village is affected by the flood and this particular portion of the village is not affected by the flood. So it provides very helpful information to relief commissioner. Relief commissioners are being provided relief to the affected person during the flood. The person which is affected during the flood, whose land has been washed away by the flood, whose plot has been totally destroyed by the flood. So we can provide the information that this particular land or parcel of land had been affected by the flood exactly. So you can provide a relief to him. Otherwise, as you all know that in the present system, it is very much possible that person having connection, good connection in government. So if he is not affected by the flood, he will get the relief. The person actually affected, they are sitting just in the offices of relief commissioners and they are not getting the proper relief. So with the help of these techniques, we can provide the exact and accurate information about the affected person, villages and all that, and that too in real-time mode. So this is the beauty of remote sensing technique, and that is basically we can contribute through flood inundation mapping. We have just mapped, as I have shown in an earlier slide also, map the flood inundation map area, and then with the capability of GIS, just overlay the village boundary map on that particular flood inundation map, which we are seeing in the slide. So after superimposing these two thematic layers, we are able to provide the information about the parcel area which is affected by the flood. Next. Here you see the another view of Radarsat data during the flood, June 27, 2004. You can very easily map the flooded area of rivers. Next. As far as flood disaster management is concerned, next, you can propose site for barrage on the basis of occurrence of flood in any particular area, just to monitor every year the flood scenario. Next. Here you can see the flood affected settlement along major river. So as I have told you, it is very easily you can monitor which settlement has been affected by the flood through the satellite images. Here you see the images that total settlement area is 433 hectare, affected settlements only 0.37 hectares. So this much information, precisely information you can to provide to government. Next. You can provide the location of shelter home also on the basis of regular studies through satellite remote sensing techniques, which area is being regularly affected by the flood and which area is on the higher side as far as altitude is concerned. So where you can provide the shelter homes to the flood affected peoples. Next. Here you see the very big study of Gorakhpur district is concerned. In last 20 years, we have mapped these Gorakhpur district and we are able to provide information which area is affected by 1 year, 2 year, 3 year, 4 year or mainly continuously for 17 years also. So these those areas which are continuously affected by the flood in last 17 years are most vulnerable to the floods, and we have to look after for their some suitable measures. So this is all about the application potential of remote sensing techniques in the field of flood management. Thank you very much.
Thank you, sir. Thank you so much for briefing about the importance and of remote sensing. And sir, with your permission, can we take any couple of questions, sir?
Okay, no problem.
Sir, there is one question from Jaspal Singh, sir. He's asking how accuracy will be the data of flood as the clouds do not get clear within 24 to 48 hours. The water goes down.
As I have told you that during the flood period, it is very difficult to monitor, but with the help of microwave satellites, we are able to provide the information about flood on each in a gap of 24 days. No problem of flood, no problem of cloud during the through microwave remote sensing technique. But as far as optical remote sensing technique is concerned, cloud are disturbing. So we have to look for the day which has having the clear sun and the satellite passes over that particular place. To overcome this problem, microwave remote sensing techniques are being used during the flood periods. That's why we are using the microwave satellite. India is also having a microwave satellite that is known as RESAT, and it is providing information during the flood also.
Sorry. Thank you, sir. As of now, these are the questions for you, sir. If anything comes to us, we will let you know through the mail.
Okay.
Once again, on behalf of NIDM and Amity University, Lucknow, and the part to convey my sincere thanks to you for taking time and giving the wonderful training session to our participants and enhancing our knowledge with your experience. Jai Hind, sir.
Thank you, Jai Hind.
Sir, one question that the cost is high, so local government don't use it. The data you give provide, is it correct, sir? Jaspal Singh.
Your voice is not clear.
Sir, the question is the cost is high, so local government do not use it.
No. This is not the scenario. Government is providing nowadays a trust on these type of information. And recently, few days back, UP government has just released the flood atlas of UP, and that has been prepared by National Remote Sensing Center, Hyderabad. So So cost is no bar. Government is providing funds for these particular type of studies, and the center like us, which is established in the state of UP. So there are other states also. They are having the remote sensing centers and regional centers. They can provide the information about the flood to the government. So there is a not a problem of fund because our center is equipped with equipments and satellite images, and we are not getting any problem as far as fund is concerned. Okay.
Yes, sir. Okay, sir.
Thank you, sir, for your extremely very well you explained that how the geospatial techniques are used in predicting the flood and other disasters. Thank you, sir, for
Thank
your
you.
presence. And
Thank you.
now I would like to continue this technical session with welcoming of Dr. Shriman. I extend my hearty welcome to Dr. Srimanta Pramanik. Sir is a senior principal scientist in the National Environmental Engineering Research Institute, Kolkata. Sir has got several awards, biogeographical profile selected for the inclusion of America's Who's Who in Science and Engineering 2017, 12th edition. Biogeographical profile selected for the inclusion of America's Who's Who in the World 2014, 31st edition. Biogeographical sketch selected for the inclusion of America's Who's Who in the World 2013, 30th Pearl and Anniversary Edition. National Institute of Health USA postdoctoral. Sir has done postdoctoral fellowship from NIH April 2000 to 2008. Sir has got award for the contribution of Research Day of University of Medicine and Dentistry of New Jersey Robert Wood Johnson Medical School, New US, on March 30, 2001. Sir has investigated more than 24 years of research experience in the area of human genetics and genomics, toxicogenomics, molecular biology, and environment health. The investigator has been involved in several R&D funded by NIH, USA, and DBT, India, and CSIR. Consultancy projects, training program, and NGT projects since 1997. Publication of 20, sir has done publication in more than 24 research papers of impact factor 106.78. So I welcome you, sir, for the today's online training program. Over to you, sir. Pramanik, sir.
Thank you very much for the nice introduction. I think you are able to hear me, right?
Yes, sir. Yes, sir.
And at the outset, I would like to express my sincere thanks to the committee for this, who are organizing this online training program on disaster risk reduction and resilience, which is being organized by University of Lucknow, NIDM, Government of India. I'm very honored actually for this, to receive this invitation to give a talk on water pollution and its mitigation. So now I will share my presentation.
कायदे से रखना, रख दो क्या फेंक देगी क्या उसी में?
Vasna ma'am, can you mute your mic, ma'am?
Is the presentation visible?
Yes, sir.
Yes,
It's
sir.
visible,
Yes,
sir.
sir. It's visible.
I don't need to do anything more, right?
Yes, sir. Yes, sir.
Okay. So I work as a senior principal scientist in the Kolkata Zonal Center of CSIR NIRI. And before I begin the talk, actually, I would like to show a couple of slides about my institute. So CSIR NIRI was established in the year 1958. At that time, it was known as Central Public Health Engineering Research Institute. And later, the name was rechristened as National Environmental Engineering Research Institute in the year 1974 by the then Prime Minister Srimati Indira Gandhi. So NIRI's vision is leadership in environmental science and engineering for sustainable development. And NIRI's mandate is to conduct research and developmental studies in environmental science and engineering to render assistance to the industries of the region, local bodies, etc., in solving the problems of environmental pollution. Also, NIRI's mandate is also to interact and collaborate with academic and research institutes on environmental science and engineering for mutual benefits, and also to participate in CSIR trust area and mission projects. So when NIRI started its journey, it was working just on a few areas like public health, sanitation, water quality, solid waste management, etc. But later, many new areas were added as the institute progressed, like air pollution, environmental system designs and modeling, environmental biotechnology, environmental materials, EIRA, environmental impact and risk assessment, environmental health. Actually, I work in the area of environmental health, environmental genomics, solid and hazardous waste management, water technology and management. So in any water is one of our most precious natural resources. Whenever we think of any disaster, so the water importance of getting quality water becomes extremely important and necessary. So water is essential for socioeconomic development and maintenance of healthy ecosystems. With increase in population and development all across the globe, there is more demand for increased allocation for surface water as well as groundwater for domestic, agricultural, and industrial sectors. So the pressure on water resources is intensifying with each passing day, leading to tensions, conflicts amongst users, and excessive pressure on the environment. Although about 71% of our Earth's surface is covered with water, but the problem is that 97% of the water on Earth is salt water, so which we cannot use for drinking and other purposes. And then 2% of water is glacier ice at the north and south poles that also cannot be used. And we are being left with less than 1% of water, which is fresh water, which can be used for drinking and other purposes. So the surface water pollution scenario in India is very bad. Surface water means water sources which are available above the lakes, oceans, lakes, rivers, streams, whatever, and other water bodies. So around 70% of surface water in India is unfit for consumption. So every day, 40 million liters of wastewater is discharged into rivers, lakes, and other water bodies. And out of that 40 million liters of wastewater, which are being released to the water bodies, a tiny fraction of it is adequately treated. So there is no treatment being done. And this discharge of untreated sewage, discharge of untreated effluents from industries and runoffs from agricultural fields mainly contribute to surface water pollution. So any water which is specified for drinking, so that water for drinking water which is used for human consumption, for cooking and drinking purpose, that water has to comply with the requirements as per Indian standards. This standard is called IS 10500-2012, and certain parameters it has to comply, like the physical parameters are there, like the color, odor, pH, turbidity, and then some general parameters are also there. And apart from the general parameters, there are toxic substances, including pesticides, radioactive substances, as well as microbiological parameters. So in order to comply as a drinking water, so all these parameters have to be satisfied. So these are like some other general parameters, like chloride, fluorides, nitrate, sulfate, etc. So the surface water problem with the is that the problem with surface water is that it is like a reservoir of microbial contamination. So it cannot be used directly for consumption. So whenever we use surface water, it has to be first treated, and then it has to comply with the standard parameters, as I told you. But this surface water is actually mainly we see contamination from viruses and bacteria. In India, if you the scenario is very bad. In India, over 1 lakh people die of water-related diseases annually, and it is attributed to a lack of safe drinking water supply, sanitation, and hygiene. And why the scenario is so bad? Because 1 in 9 people, they do not have access to clean water. And some of the most some of the diseases which are caused by polluted water, they include like typhoid, diarrhea, hepatitis A, giardia, cholera, etc. And diarrhea caused by dirty water and poor toilets kills a child under 5 years every 2 minutes. So India's economic burden of these waterborne diseases is pretty high. It's around $600 million a year. And the groundwater, as far as groundwater is concerned, we are the largest user of groundwater in the world. And it is mostly used in agricultural, domestic use, and industry. So if you use when you use the groundwater, so there will be some natural geogenic contaminants, which are these, like the fluoride, arsenic, iron. These are there in the Earth's crust, and whenever we extract too much groundwater, so these fluoride, arsenic, or iron, they get mixed with the water, and that is also not good for our health. And other than the natural geogenic contaminants, we also have like anthropogenic contaminants, which are because of our human activities, like nitrate, then the bacteria, viruses are there, phosphates are there, heavy metals are there. So it's since it's a vast area, so I would mostly concentrate my talk on these 3 geogenic contaminants. like fluoride, arsenic, and nitrate. In India, we see like it is like has become a public health problem with these contaminants like fluoride, arsenic, and nitrate. So I'll come to that one by one, and also let you know about the health effects they cause. So the nitrate contamination in groundwater is now a global issue, and it affects countries like Mexico, China, India, Iran, and Pakistan. And high level of nitrate pollution in groundwater has been reported from some states in India like Punjab, Haryana, Rajasthan, Maharashtra, Andhra Pradesh, Uttar Pradesh, and Delhi. Acceptable limit of nitrate in drinking water is 45 milligram per liter as per Bureau of Indian Standards. And this nitrate pollution is caused mostly by anthropogenic activities like extensive use of nitrate fertilizer and manure, livestock waste, fossil fuel combustion, septic systems, domestic and industrial sewage, and long-term consumption of these high concentrations of nitrate could lead to acute health risk like blue baby syndrome. It's called methemoglobinemia in infants, thyroid dysfunction, hypertension, vascular dementia, and stomach cancer also in adults. Next, we come to arsenic. Arsenic is a major contaminant in groundwater, and arsenic, it exists as an element in Earth's crust as in conjunction as compounds. And arsenic and its compounds are widely used in agriculture, livestock, feed, medicine, metallurgy, etc. Arsenic is present in the environment as both organic and inorganic forms. Actually, the organic form is not so toxic. Seafoods are rich in organic forms of the arsenic, like arsenobutane, arsenecholine. These are not so toxic, but the inorganic forms are the ones which predominate in the groundwater aquifer systems, like arsenite, arsenic 3 valent, and the arsenate, which is pentavalent arsenic. And whenever we extract too much groundwater, if there is arsenic in the earth sediments, that gets mixed with the water, and when you drink that water, it is extremely toxic. Actually, International Agency for Research on Cancer, IARC, has classified arsenic as a class 1 human carcinogen. So it is very toxic. And the sources of arsenic exposure, it's mainly groundwater. And now several studies have amply demonstrated that it also arsenic, whatever, if it is there in the water, and if you use that water to irrigate your farmlands, so that water, that arsenic can go into the food chains. So fruits and vegetables that we eat, the foods that we eat like cereal, fish, meat, poultry, all can get contaminated with arsenic. It also, we can get arsenic also from tobacco smoke and also from some industrial processes like wood preservatives, glass, and pharmaceuticals. So if you see the arsenic, the global scenario, more than these are the red dots. The big dots are actually, these areas are very highly affected with arsenic. India, Bangladesh is there. So more than 230 million people in 108 countries worldwide, including 180 million people, most of the people are from Asia, are at risk from arsenic poisoning. So the situation is pretty bad worldwide. And among the countries which are most affected, Bangladesh, India, China, Nepal, Cambodia, Vietnam, Myanmar, Laos, Indonesia, and US. These are the most affected countries. And if you see the scenario in India, it is also not very encouraging. So more than 60 million people in 20 states and 4 union territories are at risk from groundwater arsenic contamination in India. And among the states, West Bengal, Bihar, Jharkhand, Uttar Pradesh, Punjab, Assam, Manipur, and Chhattisgarh are severely affected. In West Bengal, actually, several districts which are in the floodplains of Ganga River, they are affected, like Murshidabad, Malda, Dinajpur, then the two north 24 Parganas, south 24 Parganas, Howrah. So these arsenic problem is that, like, there is inter-individual variation in arsenic toxicity. So that means even if, like, say, all the village residents, they are having a same kind of diet, they are having the same kind of water resources, but still there is variation in arsenic toxicity. There is inter-individual variation in arsenic toxicity in susceptibility to the health effects of arsenic, and these inter-individual variation could be influenced by many factors like age, gender. Like in arsenic, it is seen that males are most affected than the women, than the females. Then the nutritional status also is very important. Then the arsenic metabolism. When arsenic enters our human body, it undergoes metabolism, and these metabolites are also very toxic. So depending upon how it is metabolized in the body, so that also can show the effect in inter-individual variation in susceptibility, as well as genetics also is important, because it is seen nowadays, like many studies have amply proved that apart from these environmental and dietary factors, genetic variations in arsenic metabolism, detoxification, oxidative stress response, and DNA repair genes could affect susceptibility of individuals to arsenic toxicity, and they can influence the disease outcome. And arsenicosis is the term used for chronic health condition arising from prolonged ingestion of arsenic above dose. Arsenic level in drinking water as per BIS, Bureau of Indian Standard, is 0.01 milligram per liter. So if your arsenic level is above 0.01 milligram per liter, so that water is not fit for drinking. And how the manifestations are shown. So the first instances of manifestation of arsenic toxicity are through the skin lesions. So you get characteristic skin lesions. So these are called like melanosis, darkening of the skin, keratosis, growth of keratin on the skin, pigmentation. There will be dark spots on your chest, back, and limbs. So with arsenic, one very interesting thing is that, so if you have these melanosis or keratosis in one hand, so it will be identically shown on the other hand also. It's kind of symmetric. And these were the short-term effects of arsenic toxicity. These are the skin lesions I told you. So these are the first manifestations of arsenic toxicity. And when your exposure is prolonged, so that means long-term effects of arsenic toxicity, it practically affects all the organs and the systems of our body. Like we are going to have, with the long-term effects of arsenic toxicity, we are going to see reproductive disorders, cardiovascular diseases, hepatic and kidney disorders, vascular disorders, neurological disorders, peripheral neuropathy is very common with arsenic toxicity, hematological disorders, as well as diabetes. And if it like goes on for a very long time, even cancer like skin different forms of cancer like skin, bladder, lung, and liver cancer can happen. And how we can measure the amount of arsenic if you think that you are consuming arsenic-laden water. So that we can determine through a biomarker. Biomarker is like a measurable indicator that can be used to detect any biological alterations or disease condition in human body. So there are several biomarkers that are used for arsenic toxicity, like blood, hair and nail, and urine. So these are used for measuring arsenic exposure in epidemiological studies. We can determine the concentration of arsenic in these biomarkers to know whether that person has been affected with arsenic toxicity or not. And what about the treatments of chronic arsenic toxicity, its prevention and controls? Practically, there is no effective therapy for arsenic contamination, arsenic toxicity, and it becomes arsenicosis. Actually, it becomes irreversible after a certain stage. It cannot be reversed. And although use of chelation therapy has been mentioned for arsenic, for removing the arsenic stores in our body, but it is not fully established. Only option is to provide safe water for drinking and cooking, and also monitor early signs of arsenic poisoning in vulnerable population and provide suitable interventions. Now there is like more awareness among people, especially I know about in West Bengal. So people are more about, because this arsenic problem has been there for a very long time, and there is enough awareness has been generated through education, information, and communication. And government also, as well as some NGOs, are trying to provide technologies for removing arsenic from water. Actually, NIRI has some technologies. At the end of my talk, I'm going to show you that. Now, there is another major contaminant in groundwater is fluoride. So fluoride also is its effect is not that severe as arsenic, but still fluoride also is very, very toxic. Actually, fluoride is an element which is physiologically essential for normal growth and development, and because it plays a very important role in bone and teeth mineralization. So it also exists abundantly in Earth's crust in combination with other elements as fluoride compounds. So fluoride is called a double-edged sword because fluoride in very small amounts, it prevents dental caries. So in some countries, like still use fluoridated water, or like for infants actually, fluoride drops are given to prevent dental caries. But ingestion of excess fluoride can cause very harmful effects in mineralized tissues of our body, like teeth, bones, and as well as soft tissues. So that thing is called fluorosis. So the sources of fluoride exposure also is, it can happen mainly through groundwater, but it can also happen through foods, beverages, fluoride supplements, dental products. Like some of our toothpaste and like dental products have fluoride. And fluoride supplements also some people take. So fluoride level in drinking water as per Bureau of Indian Standard is 1 milligram per liter. So anything above that level is should not be taken. Actually, in drinking water level, fluoride level should be less than 1 milligram per liter. So fluoride is also endemic across the globe. So it is not as severe as arsenic, I told you, but still many countries, like almost like 25, 26 countries around the globe are having fluorosis problem, like China, India, East and North Africa, Mexico, Argentina. These are the countries which are mostly affected by fluoride. So high in India, the scenario is also not very good. So approximately, if you see the map here, the red color, more red color means more, these are, the effects are more severe. Like these area are more fluoride affected regions. And like almost like whole of India except the northeast, some states are, and some are not affected. So approximately 12 million people are affected in more than 230 districts in 20 states in India. So Rajasthan, Gujarat, and Andhra Pradesh are the worst affected, while Punjab, Haryana, Madhya Pradesh, and Maharashtra are moderately affected. West Bengal also is affected, like 7 districts of West Bengal are affected, have been considered to be fluoride endemic region as per the PHED report. So in fluoride also there is a, although it is mostly, it was mostly believed that it happens because of environmental exposure only. But nowadays many studies have amply demonstrated that the genetic variation in some candidate genes also may contribute to inter-individual variation in susceptibility to fluorosis. So fluorosis could result from a complex interplay between genes and specific environmental exposures, including dietary patterns of fluoride intake and other nutrients. So these are the types of fluorosis. So on the left panel that you see, like dental fluorosis, skeletal fluorosis, and non-skeletal fluorosis, these are the major types of fluorosis that we see in India. And the panel on the right side, actually waterborne fluorosis means it comes from water, like from where we are getting. And the coal burning fluorosis and brick tea type fluorosis, it is not seen in our country. It is mostly seen in China. So one by one, I'll come to that. So dental fluorosis, it is caused by slight and optimal level of fluoride. Like I told you, the skin lesions are the first manifestations of arsenic toxicity. Similarly, the dental fluorosis is regarded as the first signs of fluoride toxicity. So if you go to an endemic region and where fluoride level is higher than the safe limit in drinking water, so you can see among the children and young people that they are suffering from this dental fluorosis. So this is a developmental defect which is characterized by hypomineralization of tooth enamel. Your enamel of the tooth gets affected. Enamel becomes porous. So the clinically affected teeth could appear to have white spots. Like this is a mild case of fluorosis. The second one is moderate, and the last one is severe. So when it is severe, you can see the pitting or mottling of enamel. Enamel become very porous. So skeletal fluorosis, it is caused by high fluoride exposure over a prolonged period of time, and it affects young as well as the elderly. This lady, she cannot stand erect because she is suffering from skeletal fluorosis. So with exposure over a long period of time, this high fluoride and results in bone and joint problem, like leading to bone deformities and increased risk of fracture and other allied problems. Like this person is bent, the knee is bent. Like that person cannot stand straight because this has happened because of skeletal fluorosis. There is too much fluoride toxicity in that individual. Then the case, then the another instance, this is also seen in India. This is called non-skeletal fluorosis. It affects the non-skeletal fluorosis affects all the soft tissues and organs of our body. Excess fluoride can be detrimental detrimental nervous system, endothelial system, as well as the neurological system. So these two fluorosis I told you, coal burning fluorosis and brick tea type of fluorosis, this is not seen in our country. This happens because of combustion of coal and coal bricks. And so what happens, they release gaseous and aerosol forms of fluoride, which is there in the coal and coal bricks, into the environment. And then it ultimately enters the exposed food products and it causes fluorosis. So this is prevalent in many rural areas of China, especially Guizhou province in southwest China. And there is another interesting thing which is called brick tea type fluorosis. These are like the tea leaves which have been finely ground and they have been compressed into a brick form. This is a very ancient tradition which is followed in China. And this brick tea leaves, they have higher content of fluoride because of these leaves are very aged. So brick tea type of fluorosis also is an endemic fluorosis caused by habitual consumption of large amounts of brick tea. So it is mostly prevalent in western and northern parts of China. So like how do you measure whether a person has been affected with fluoride toxicity? As I told you, we can analyze some biomarkers like urine, saliva, like a hair and nail to know the exposure level of fluoride in some particular individuals. So urine is like a non-invasive way. Plasma, saliva also is like a non-invasive biomarker. The plasma, blood, these are like invasive biomarker. And as hair and nail also can be used as a biomarker for measuring fluoride exposure. And what about the treatment of fluorosis, its prevention and control? Similarly with arsenic, like fluorosis is irreversible after a certain stage. Like once it crosses a certain stage, it cannot be reversed, even with medications or supplements like that. So medical treatment, there is no specific treatment for fluorosis, only supplementation with some vitamins and antioxidants and calcium can be the treatment. And only option is to provide safe water for drinking and cooking. And our awareness generation also through information, education and communication also would be very effective. So see, as I told you, CSIR NEERI has some technologies in the water sector. So this NEERI jar, this is a portable instant water filtration system, which has been used during some disasters like situations like Ayla. It happened in West Bengal in 2009, and also in disaster affected areas of Uttarakhand state in 2013. So this is a gravity operated simple water purification system. It is operational costs are very low. Like unit cost is rupees 5,000 to 6,000 and operating cost is rupees 3 per 100 liter. And this also has won some international awards, this NEERI jar. And it doesn't need electricity. It's a gravity operated system. And its installation is also very simple. NEERI also has some technologies in the arsenic and fluoride sector, like there is a chemo de-arsenification household unit system, which has been installed in Chhattisgarh, in some places in Chhattisgarh. This process involves using Fenton's reagent to remove arsenic from water, and it works for arsenic concentration up to 2000 ppb. So it can reduce arsenic concentration in water to a safe level, like less than 10 ppb. And a typical unit of 30 liter can serve a family of 5 and 6 persons. And as unit costs, this also doesn't need electricity. It's also a gravity operated system, and unit cost is like 3,000 to 4,000 rupees. And there is a solar energy based electrolytic defluoridation system for removal of fluoride from water. So these also are there in many like MP, and this is using a aluminum electrode for fluoride removal. It removes through. It works up to a fluoride concentration. It's suitable for treatment of raw water with fluoride concentration up to 10 milligram per liter. And quality of sludge produced also is much less than the conventional treatment method. And capacity is 2,000 liter per batch in 3 to 3.5 hours. And cost of treated water is rupees 20 to 30 per 1,000 liter. This also has won some international awards, this particular technology. And then there is a hand pump attachable iron removal plant, also has been installed in some states in India. This is done mainly through aeration and oxidation and precipitation, sedimentation and filtration. So this is also a very simple process. So nowadays there are many technologies available for removal of arsenic and fluoride from water. So this is with this I come to the end of my talk. Thank you very much. Thanks very much for your kind attention.
Thank you, sir. Your talk was very informative and you very well explained the arsenic and fluoride pollution in water and their removal also you very well explained. So I think so no questions are there, sir.
Okay. Thank you very much.
Thank you, sir, once again for giving your time and telling us about the various issues of water pollution. So
Thank you very much. Thank you, madam.
Thank you, sir. So we are ending this
Thank you.
second day online training program. So we will meet tomorrow again at 11 a.m. On the third day of the training program. So I thank to all the participants for taking time and attending the program. Hope this program was informative to you all. Thank you, sir.
Thank you.
We are ending this program. Gautam, sir.
I am audible.
Yes, sir.
What happened?
Sir, the lecture was finished, so we ended the program.
Concluding marks are told right now.
Yes, sir.
So shall I end the program?
Yes, sir. Yes, sir.